Every year, billions of dollars are just bled from mega projects.
Oh, easily billions.
Yeah. I mean, we're talking skyscrapers, suspension bridges, massive industrial manufacturing lines. And it's not because the engineers don't understand the physics of what they're building.
Right.
It's because somebody, somewhere, lost an email.
It sounds absurd, but it's completely true.
It is. You walk past a massive construction site, with those giant cranes hoisting structural steel hundreds of feet into the air, and you're looking at an environment with incredibly high stakes. We are building physical infrastructure meant to last for centuries. There is zero room for error.
Absolutely zero.
So, welcome to the deep dive. Today, we are unpacking a single really information-dense source. It's an article titled Mastering Project Complexity with NotebookLM.
It's a great piece.
Yeah, it really is. And our mission today is to explore exactly how project leaders are using this specific tool from Google to control just massive amounts of information, prevent these catastrophically expensive mistakes, and basically tame the pure chaos of large-scale physical projects.
And that framing, it gets right to the heart of the modern engineering dilemma, I think. Because the fundamental challenge of building something massive today, it has completely shifted.
How so?
Well, we live in an era of just absolute information overload. The key to successful engineering or, project management is no longer holding all the answers in your head.
Because you can't.
Right, that is humanly impossible now. The true competitive advantage is knowing how to instantly locate and verify those answers across a completely fragmented landscape of data.
Okay, I want to pull on that thread of fragmented data because to really understand why a tool like NotebookLM is gaining traction, we first have to look at the anatomy of project failure.
Yeah, we have to look at why things actually break down.
Exactly. And the source makes this striking point right out of the gate. These massive multi-million-dollar projects rarely fail because of a lack of technical expertise. I mean, the people pouring the concrete and calculating the load limits, they know exactly what they are doing.
Right. They are incredibly skilled. The failure point is almost entirely structural information management.
Okay, unpack that a little.
So you're dealing with an environment where critical constraints are just constantly getting buried. Think about the life cycle of, say, a major commercial build. You don't just have a single blueprint.
Right, I wish it were that simple.
It never is. You have the original architectural drawings, plus hundreds of mechanical and electrical submittals, and then you have constantly evolving building codes, supplier contracts, environmental impact assessments,
Oh, man.
and a daily avalanche of RFIs, requests for information.
It's like trying to cook a highly complex 5-star meal, but the recipe has been torn into 50 pieces and hidden inside different kitchen cabinets.
There's a perfect analogy.
Because it doesn't matter if you have a Michelin star chef in the kitchen, right? They're going to burn the sauce while they're frantically running around looking for the next instruction.
Exactly. And taking that kitchen analogy just a step further, imagine if the sous chef, the pastry chef, and the line cooks are all communicating through completely different systems.
Oh, chaos.
Complete chaos. In engineering, information is moving slowly across dozens of email threads, proprietary shared drives, half a dozen different contractor software platforms.
Right.
And when information moves that slowly, the physical project itself moves slowly. And in construction, delay is the breeding ground for catastrophic mistakes.
Because people rush.
Or they just miss things.
Right.
A structural constraint gets missed because a junior engineer couldn't locate the latest addendum. Or, a critical decision made 3 weeks ago by the client simply vanishes into an archived email thread.
Wow. So the result is that you have these incredibly intelligent, highly trained professionals, people who went to school for years to understand fluid dynamics or structural engineering, spending a massive portion of their week doing what? Searching.
Just searching.
They essentially become highly paid librarians.
Which is an incredible misallocation of human capital. I mean, the stakes are just too high for that kind of delay.
Yeah.
When you have a crew standing by to pour 1,000 tons of concrete, you cannot wait 3 days to confirm a load calculation from a modified mechanical drawing. You need to know immediately.
Right, because time is literally money.
Exactly. And if you don't have that answer, you face 2 terrible choices. You either guess, which compromises the safety of the entire structure.
You can't do.
You can't. Or you halt the project, which burns thousands of dollars an hour in idle labor and equipment costs.
Okay, let's stop right there and unpack this, because I have to play devil's advocate for a second.
Go for it.
When a lot of people hear the term AI, they immediately think of hallucinations.
Oh, sure.
We've all seen the headlines about AI confidently generating, completely fabricated legal cases or telling people that a dog is a type of vegetable.
Right. The AI confidently lying.
Exactly. And if I am the lead engineer on a suspension bridge, I cannot, under any circumstances, have a chatbot guessing about structural load limits or tensile strength. It sounds terrifying.
It would be terrifying.
So how does a generative AI tool actually function in a high-stakes environment without introducing massive new risks?
That is the single most important hurdle to clear here. And it requires looking at how NotebookLM's architecture is fundamentally different from a standard public-facing large language model.
Okay.
Standard AI tools are designed to predict the next most likely word based on the entire public internet.
Right. They just scrape everything.
Everything. And that vast, unfiltered data set is exactly where those hallucinations breed. NotebookLM, however, operates on a principle called retrieval augmented generation, or RG, but it's implemented as a strictly closed loop.
A closed loop meaning it's fenced off from the internet.
Completely fenced off. Let's use an analogy. Standard AI is like a brilliant but incredibly reckless intern who spent a week reading every book in the public library, and now they're just answering your questions from memory.
Okay, yeah.
Sometimes they are spot on, and sometimes they completely invent a historical event.
Right.
NotebookLM is more like a highly focused, meticulous paralegal that you have locked in a room.
Locked in a room, okay.
You slide 10 specific file folders under the door, your project charters, your specific building codes, your engineering drawings, and you say, you can only answer my questions using what is in these folders.
Okay. That significantly lowers the temperature. Because if I only give it verified project data, its universe of knowledge is entirely restricted to my verified facts.
Exactly.
But even so, how do I actually know it's giving me the right number from those folders? I mean, I still can't just take its word for it, right?
Which brings us to the core mechanism that makes this viable for engineers. And what's fascinating here is the concept of absolute citation.
Absolute citation.
Yeah. When you ask NotebookLM a complex question about a load limit, it doesn't just synthesize an answer and say, trust me. It acts as a retrieval engine. It highlights the exact section, the specific paragraph, and the page number of the uploaded document it pulled that data from. It is giving you the answer alongside the receipts.
So it's fundamentally shifting the paradigm of how we interact with the AI. You aren't trusting the AI's judgment at all.
Not at all.
You are just using the AI's retrieval speed to accelerate your own human verification process.
That's it.
It's the difference between asking a colleague, hey, what's the load limit? And them casually saying, I think it's 50 tons, versus them saying, it's 50 tons, and here's the physical binder, open to page 47, paragraph 3, where the structural engineer signed off on it.
I'd actually argue the distinction is even sharper than that. Nobody in civil engineering or manufacturing is ever going to make a final decision based on an AI's text summary.
Of course not.
But when that AI takes you directly to page 47 of a 900-page mechanical submittal in 3 seconds, instead of you spending 4 hours hunting for it, the operational bottleneck is completely broken. You, the human, still read page 47. You still verify the math. The AI just did the heavy lifting of finding the needle in the haystack.
Okay, let's look at what breaking that operational bottleneck actually looks like on the ground. Because the source details a few different environments, and I want to weave these together, it really paints a picture of how technical data is parsed.
Let's do it.
Let's look at a vertical build first, like a commercial high-rise. Picture a subcontractor submitting an RFI because they want to modify an HVAC installation, and they need to know if it changes the load requirements for the third floor mechanical room.
Okay, so on a traditional project, answering that specific RFI sends the project engineer on a massive treasure hunt.
Right.
They have to locate the structural drawings, pull up the mechanical submittal for that specific HVAC unit, cross-reference the local municipal building code, and manually verify the new load calculations against the floor's capacity.
Which sounds painful.
It is. Depending on how disorganized the project's cloud drive is, that is a multi-hour, potentially multi-day task.
Here's where it gets really interesting, though. Surely one HVAC question doesn't stop the concrete guys on the floor above. Let's talk about the critical path here. Why is the project manager sweating over this single RFI?
because of cascading dependencies.
Ah, okay.
The HVAC installation might be holding up the drywall contractors,
Mm-hmm.
and they are holding up the electricians who are holding up the painters.
Dominoes.
Exactly.
Yeah.
If you delay answering that single RFI, you aren't just delaying the HVAC crew, you are shifting the entire downstream schedule.
Mm.
And in a major build, a stalled crew costs tens of thousands of dollars a day.
So instead of the manual treasure hunt, the engineer uploads the structural plans, the HVAC submittals, and the building code PDFs into the closed-loop notebook.
Right.
And they ask, does the proposed HVAC installation exceed the third floor load limits? Now, here's where I get hung up on the mechanics.
Yeah.
I understand an AI reading a text document like a building code. That makes sense. But how does an AI read a structural drawing? Isn't a PDF of a blueprint basically just a giant image to a language model?
Well, historically, yes. But that's where the multimodal capabilities come into play. Modern systems aren't just reading raw text strings anymore. They are performing optical character recognition, OCR, and semantic mapping simultaneously.
Okay, what does that mean in practice?
It means when it looks at an engineering PDF, it is actively identifying the text annotations, the tables of load values, and the spatial relationships of the callouts on that drawing.
Oh, wow.
Yeah, it maps the semantic relationship between the words HVAC Unit B on the mechanical submittal and the load capacity table on the structural PDF.
So it's actively connecting the dots across completely different formats of data.
Exactly. It returns the answer in minutes, providing hyperlink citations to the exact page in the structural drawings and the specific clause in the building code.
That's wild.
The engineer clicks the links, verifies the math is correct, and approves the RFI. The domino effect of delays is stopped cold.
Okay, take that vertical complexity, right, and stretch it horizontally over a 2-mile span, and you get into civil infrastructure.
Whole different ballgame.
Building a suspension bridge introduces an entirely new layer of friction. You aren't just dealing with the physics of concrete and steel anymore. You are dealing with a mountain of legal and regulatory constraints.
Oh, absolutely.
Geotechnical reports, environmental impact assessments, Federal Transportation Authority regulations.
And the friction there occurs when physical design clashes with regulatory compliance. Imagine a contractor on that bridge project proposing a modification to the deck reinforcement pattern just to speed up the concrete pouring.
Sounds like a standard request.
It is, but before the lead engineer can approve that, they have to ensure the new pattern still satisfies the baseline structural safety requirements and doesn't violate any of the complex Transportation Authority regulations governing that specific highway.
And without a retrieval tool, you are flipping back and forth between raw engineering calculations and massive, dense books of legal regulatory standards. It's basically two completely different languages.
Exactly. But by preloading all those documents into a unified project notebook, the engineer can ask a synthesized question.
Like what?
Like, does this specific deck modification comply with both our internal load requirements and the federal transportation standards? And the system instantly highlights the relevant load calculations and side-by-side matches them with the specific regulatory clauses.
It bridges the gap between the design intent and the legal constraint.
Precisely.
Now, let's pivot away from concrete and steel entirely. Let's look at product development. Because the source uses the example of an industrial pump, which introduces a totally different type of data constraint, the tabular spreadsheet.
Yeah, spreadsheets. The bane of every project manager's existence.
Right. Let's say a manufacturing team is designing a complex pump, and late in the game, the client drops a bomb. They say, actually, we need this pump to handle a 15% increase in its operating temperature range.
That is a classic nightmare scenario.
Why is it a nightmare?
Because a 15% increase in temperature doesn't just change one isolated part. It cascades through the entire design. It impacts the materials listed in the bill of materials, the BWAM. It alters the required thermal testing procedures. It might even put the company in breach of supplier contracts if a specific outsourced component is no longer rated for that higher heat.
So you have to instantly find the weak link in the chain. Again, a bill of materials is usually a massive spreadsheet with thousands of rows of part numbers, materials, cost codes.
Right?
How does a text-based AI parse a massive grid of tabular data?
It uses semantic search to understand the structure of the data, not just the raw text.
Okay.
It understands that a row represents a specific component, and the columns represent attributes like material type or maximum thermal tolerance.
Oh, I see.
So when the project manager uploads the BOM alongside the testing procedures and supplier contracts, they can ask, if the operating temperature increases by 15%, which specific components in the BOM exceed their thermal tolerance.
So wait, it scans all those thousands of line items, maps the new temperature against the thermal threshold column, and spits out the failing parts?
It does. And crucially, it cross-references that with the supplier contracts to see if those specific failing parts have alternative sourcing agreements already in place.
That is incredible.
The project manager can evaluate the cost and schedule impact of this client request in a matter of minutes, rather than spending a week just trying to figure out if the temperature increase is physically possible.
It's acting as the connective tissue between the sudden real-world problem and the documented constraint.
Exactly.
Whether it's a structural drawing for a high-rise, a federal regulation for a bridge, or a massive spreadsheet for a pump, the AI is translating and connecting the friction points.
And consider the broader implications of that. We've been talking heavily about technical constraints, physics, supply chains, regulations. But a massive source of project friction is purely interpersonal.
Yes, this brings us to what the source identifies as the ultimate project monster: scope creep.
Ah, scope creep.
We've solved the physics, but what about the human memory? Because the complexity of a project isn't just about thermal limits. It's about shifting client demands and the reality that people simply forget what they agreed to.
This raises an important question, right? The source makes a fascinating observation here. Scope creep rarely happens because of deliberate sabotage or malice.
It's not usually a villain in a boardroom.
No. It almost always happens because people misremember previous decisions. Someone on the client side insists, I know we approved this specific material change during the Phase 2 review,
Right.
and the lead contractor says, no, we explicitly tabled that discussion. Suddenly, a multi-million-dollar project grinds to a halt while two teams argue about a conversation that happened on a Tuesday 3 months ago.
It's the highest stakes game of he said, she said imaginable. And normally the only way to solve it is to dig through thousands of emails and meeting transcripts to find the proof.
Right. And this is where NotebookLM transcends being just a technical reference tool.
Right.
It becomes a searchable, unified memory for the entire project.
Unified memory.
Yes. By systematically ingesting every meeting transcript, every client email thread, every change order, and every design revision, it creates an immutable record of decisions.
It's basically the ultimate corporate receipts machine. It completely removes the he said, she said from multi-million-dollar contracts.
Exactly. When that dispute arises over the Phase 2 material change, the project manager doesn't argue. They simply ask the notebook, did the client approve the material specification change during Phase 2?
And it finds it.
The system immediately retrieves the specific email from the client or the exact paragraph from the meeting transcript, complete with a timestamp. By maintaining a shared, verified knowledge base, you completely eliminate interpersonal disputes.
Wow.
The project scope stays firmly under control because ambiguity is removed from the equation.
So what does this all mean? If we pull all the way back and look at the big picture, if the AI is instantly answering technical RFIs, if it's cross-referencing federal regulations, parsing massive bills of materials, and instantly pulling up meeting receipts to verify scope, what does the human project manager actually do all day?
That is the most critical takeaway from this entire technological shift.
Yeah.
NotebookLM does not replace the engineer, and it certainly does not replace the project manager.
Yeah.
What it does is systematically remove the mechanical robotic work of cross-referencing. It takes away the librarian work.
So if we strip away the busy work of digging through folders, do project leaders actually get to be leaders again, rather than just administrators?
That's exactly it. The human brain is uniquely powerful at solving complex, novel physical problems. We are incredible at coordinating teams on the ground, reading the political dynamics of a stakeholder meeting, anticipating unseen risks.
Yeah.
But human beings are terrible at manually scanning a 500-page PDF for a single sentence about an HVAC load limit.
We really are.
When you use AI to handle the retrieval, you grant the human team what the source calls operational leverage.
Which directly impacts the two biggest constraints of any project: time and scope. For time, managers can summarize requirements and prepare stakeholder updates in minutes. For scope, they can instantly analyze the impact of a change request across the entire project ecosystem.
It gives humans the leverage to actually use their hard-earned expertise. It allows project leaders to stop searching through nested folders on a cloud drive and start spending their time coordinating crews, reviewing the actual engineering designs, and solving the complex real-world problems that arise every single day on a job site.
Yeah.
It turns static documentation into a dynamic intelligence system. When you are building physical infrastructure that must safely stand for decades, that level of operational clarity is the difference between a project that bleeds money and constantly dressed off schedule and one that is executed with absolute precision.
You are finally freeing up the experts to actually do the expert work.
Precisely.
To quickly recap what we've unpacked today, NotebookLM is tackling massive project complexity, not by doing the engineering for us, but by acting as an ultra-fast retrieval engine. It instantly connects humans to the exact blueprints, BIMs, codes, and meeting transcripts they need to make safe, rapid decisions.
Yep.
It relies entirely on closed-loop citations, meaning it eliminates the risk of hallucinations by strictly pointing to your verified source material. And it does all of this to give project leaders their time and, honestly, their sanity back.
Absolutely.
So I want you, the listener, to think about your own workflow for a second. Regardless of whether you are building a suspension bridge or managing a software launch, look honestly at your week. How much of your valuable time is spent acting like a librarian, frantically searching for a lost email, a buried PDF, or a forgotten requirement, rather than acting like a leader who is actually applying that information to solve problems?
And as you reflect on that, consider the broader trajectory of where this is all heading. If we are entering an era where AI can perfectly recall and cross-reference every engineering spec, every building code, and every client email in seconds,
Right.
will the future of engineering and project management as a whole depend much less on our ability to memorize the right answers and rely entirely on the human skill of asking the right questions?
A brilliant and provocative point to end on. Thank you so much for joining us on this deep dive. Stay curious, keep exploring, and we will catch you next time.